This conference will now be recorded.
Welcome, everybody. My name is Dr. Mary Beth Neely. I'm the scientific coordinator for Geo Aqua Watch. Our director, Gada El Sarafi from Deltares, could not be with us today, but it is my pleasure to introduce our third and final speaker in the series of water quality forecasting that we have scheduled leading up to our biennial meeting. The talk today will be given by RocaMora. She is with the Instituto de Ciencias Marinas de Andalusia in Spain, and she has won quite a lot of awards. She received her master's degree in GIS and data science from Esri. During that time, she was awarded the UCV Innovation Award and the Extraordinaire Prize for highest grade point average. And also the Esri Young Scholar Award. She has also received her master's degree in integrated coastal zone management from the University of Cadiz. During that time, she received a extraordinary prize a couple of years later, 2020 and 2021, from that university, and currently is a PhD candidate at CSIC. Um, she is especially interested in research on oceans, climate change, and especially mapping. She currently works with Global Seagrass Watch with DLR in Berlin, and has developed a tool on Google Earth Engine, which of course is quite interesting. Mar is going to share her research with us today on water quality prediction. Just want to ask everybody who's on the call to please mute if you're not speaking. And if for some reason we lose connection with Mar, we're going to hang out here and hopefully she'll recognize that and join back and be able to pick up where she left off. Today's talk is being recorded and I will post it on our website in a few hours. Mar, you can go ahead and take it away. Thanks.
Yeah, thank you. Thank you for introduction and thank you all for joining. I'm going to share my screen. Hopefully you see everything.
We do.
So today,
Yes.
thank you. Today I'm going to talk about how monitoring coastal water quality, especially using Sentinel-2 and Landsat-8 satellites, and how can we use these tools as early warning tools. So she already introduced me very well. My PhD is centered especially in aquatic remote sensing. I started working more in water quality, and now I'm working. I'm more focused in this global seagrass watch project about seagrasses, but it's also related to water quality. So this is my institute. I'm inside the Department of Ecology and Coastal Management, especially inside Earth observation. And we have this website where I'm gonna show you later that we have a viewer with all the products for water quality, so you can check it there. So this is gonna be the roadmap. I'm gonna start talking about water quality in coastal areas. How can we apply Earth observation for that? And I'm gonna present two case studies. First, a coastal lagoon called Menor in the south of Spain, and a delta that is more focusing coastal waters itself. So all my work is especially focused in the Mediterranean Sea, and these two cases are located in here in the Mediterranean part, and our institute is here in the southern part of Spain. So first, talking about water quality, I would like to introduce coastal regions as interfaces between atmosphere, hydrosphere, and lithosphere, and to highlight that these are very dynamic environments, very sensitive to pressures, and especially to climate change, being affected by erosion, floodings, pollution, sea level rise, extreme events, and also water quality impacts. And we have in this area the 60% of global population, so this water quality is affecting to more than half of the people in this globe. But first, why is water quality important? Well, we can use water quality also as a proxy, as early warning tools to detect unstable aquatic environments. Marine coastal sediments and pollutants can reduce available sunlight in the water column for native photosynthetic benthic organisms, so they can die in the bottom. Also, high nutrients inputs, mostly from rainfalls, can generate proliferation of harmful algal blooms, generating eutrophication and in some of the cases anoxia. And these harmful algal blooms can also give us clues about the global carbon cycle. And one of the cases is monitoring sediment plumes through these extreme rainfalls, giving us assessment of the water quality impacted by human activities and coastal environments in extreme cases. The main contributors are anthropogenic processes, and we're going to focus today in land runoff and land use change in these two cases, especially in the coastal lagoon. And the major constituents affecting water quality could be these five. And we will measure dissolved organic matter, also high inorganic, and these chemicals from contaminants can also be attached to these sediments that are in the water column. Mostly, this is like the classical classification of natural waters. Case one waters are those waters whose inherent optical properties are determined by phytoplankton. So these are mostly open ocean waters that can change the color of the water mostly by phytoplankton blooms. Whereas case two waters are all the other waters. It's like the box. Uh, Most of the coastal waters, especially affected by these rainfalls and the turbidity, and what it can have these inlet waters containing colored dissolved organic matter and also inorganic. So this could be the two cases: case one on the left, case two on the right. Case one could have these low turbidity levels, and its changes in color could be due to phytoplankton. In the other side, we have the suspended sediment, terrestrial runoff, dissolved organic matter. So what we can see here from space is that the surface has changing color depending on the chemical particles floating on the water. And I want to keep this in mind. Coastal waters have this complexity and variability of colors, and we can measure and transform these colors. So how can Earth observation do here? We mostly use optical sensors. This is the range of the wavelength we are using. We also have the near infrared and the red edge that is going to be very, very useful, especially for chlorophyll. So these sensors can give us insights about the water quality. These optical sensors are passive sensors, so the light comes from the radiation of the sun, and what we are measuring is the energy that is reflecting and captured by the sensor. So this light is measured in radians, and we can measure it from a satellite with the sensors on board. So the energy leaving from the water has three pillars that could be the sunlight, the fluorescence of some components, and the scattering. So how is this energy being dispersed in the water by the presence of suspended sediments? So from the satellite, we have a synoptic information. So we can see the spatial variability through all the image. On the left, you can see turbidity and how it's changed by the currents. And on the right, we have a hard foam algal bloom. So these particles, I like to explain it this way because it's very easy to understand. These particles are painting the water like watercolors. So through these algorithms, we can transfer the colors into water quality information. So this discipline is called ocean color. So we are monitoring the particles, taking valuable information about the ocean. But we have to understand that we are measuring millimeters to a meter depth from the ocean. So it's like a radiography. So this is how it works. We have the energy from the sun, and this energy goes into the water and has interferences with the light, and how it's refracted is the information that we are getting. We can have information about the phytoplankton through chlorophyll A, dissolved organic matter through colored dissolved organic matter, or inorganic suspended materials about this variable, and also through turbidity. So this is the optical behavior of the water. Mainly, you can see the spectral signatures of pure water that go down with wavelength here, the chlorophyll concentrations that have two peaks. Sorry. And you can see here the spectral signature and the particulate matter. For the coastal areas that are very dynamic, we really need high resolution. And we are going to use Landsat 8 and Sentinel 2 because they have 30 and 10 meters spatial resolution. It's open access. They have the bands we need. And we have these revisit times. But we have a challenge with this, that these satellites are designed for land purposes. So we have to we have to adapt the algorithms. So it is very important to implement these applications to generate good atmospheric corrections, because 90% of the signal we have from the satellite, it comes from the atmospheric error. So 90% of the measured signal is noise. So it's very important for coastal applications to generate and apply good atmospheric corrections. Here you see the top of atmosphere in gray, and how it's corrected with two different atmospheric correctors. You see there's a lot of noise in the top of atmosphere, and we have to apply a good atmospheric corrector to have this signal closer to in situ measurements and take out this noise. So we need to work with level 1 images. Moving to coastal lagoons, this is going to be the first case study. Coastal lagoons occupy the 14% of the world's coastline, is one of the most productive habitats in the world, and have a lot of biodiversity in there. Are subject to diverse transformation and uncoordinated management plans. So we need synoptic information that can be transferred in between the stakeholders. Sorry. So these environments are very sensitive and vulnerable and have signs of deterioration that we can take as early warnings. And they are also sentinel systems controlling water and nutrient fluxes, eutrophication, and pollution processes. So this is going to be our first study case. This is the lagoon. The max depth is 6.5 meters, so it's so shallow. Here we have the total area, and it's connected through 5 shallow inlets to the ocean and to the land through weddies. But we have a strong land use modification on the left of the coastal lagoon. If you see, here we have information from the 90s, but it was already changed before. So we have here a lot of permanently irrigated land that creates a lot of excess of nutrients and fertilizers draining into the lagoon from this freshwater discharge. And if you check this this light yellow turns into fruit trees and berry plantations that need extra water. So here is the image. In the Mediterranean, we have what is called cold drops, that are extreme rainfalls that generate a lot of runoffs. These runoffs take the nutrients from the land and goes into the lagoon, generating this type of impacts with eutrophication and oxygen, taking out the oxygen from the lagoon and generating these massive deaths. So this is the cold drop from 2021 that we're going to monitor. Here you can check in the Sentinel-2 image on the left how the increase of turbidity and chlorophyll A generates an acute eutrophication process. Then we have anoxia and massive dead fish and crustaceans, and the loss of seawater quality and deterioration of seagrass communities that lives in there. So before this collapse, we had a lot of deterioration signs before that they were not really taken into account for decision making. So regional government has these constant field-based campaigns for clarity, turbidity, chlorophyll A temperature, and other variables in several points along the lagoon, but this lagoon is huge. This information is key, but it's also expensive and time consuming. And most important thing, it has a lack of spatial variability and the distribution of water quality. So the approach that we proposing here is using some of the in situ samples from the lagoon to calibrate and validate satellite data to have information across the stakeholders with a synoptic information across the lagoon. So we can have the parameters of chlorophyll A and turbidity for water quality monitoring. And we know that with the threshold of 3 milligrams of chlorophyll A, for example, then a collapse is coming because it's seen also in situ measurements. So we are going to have here this information with a spatial resolution of 10, 30 meters with Landsat 8 and Sentinel-2, and a revisit time when mixing them of around 4 days. So here you can check the spatial resolution that is very important for coastal areas and how Sentinel-3 that is designed for monitoring water bodies and ocean has a spatial resolution that is not enough for our case study. So we decided to use these two satellites. For that, we took this information from the in situ point, and then we generated this validation for chlorophyll A and turbidity. So you can see how the regression for chlorophyll A it's very, very nice, while turbidity It's nice, but it's not enough. It's evaluating a higher value. So if you want to check more information about this, we already published this paper, and there you can see how spatial temporal monitoring of vulnerable and affected water quality ecosystem, like this case study in the Menor that is very well known around. Using a multi-sensor of 10, 30 meter, we have a systemic earth observation monitoring, identifying these water quality patterns along the lagoon, and you can check here how this principal wadi has all this discharge, and we can see which areas are more critical and where can we manage before, or where are these inputs coming from, so stakeholders have also the information to take action. This near real-time operational and automatic information it's available in a platform that I'm going to show you now. And it's easy to implement for remote coastal water quality change detection. And we can enhance climate change impact by monitoring these early warning indicators. So this is the website of my institute where we have all this information. We mostly monitor the south, but we have a case study here in Menor, so you can zoom in here and you can check the last image with all the processors there. So I encourage you to enter and check. And we have the historical series since 2015 for water quality. And this that is a well-known case study is the first ecosystem in Europe with its own legal personality. That is something new in Europe. And we also have another study on these macroalgal blooms that appeared here after the collapse of the lagoon. So if you want more information, you can also check this paper and how they managed to do this machine learning algorithm detection for macroalgal extension, and also to have this information for management to remove them. So I'm going to pass to the second case study that is more in coastal waters, more open, not like an lagoon. It's a delta. And we are going to study this Gloria storm in 2020 that it was unprecedented in Europe. And this is located in Catalonia. So you can check here the severity of these extreme events, making the littoral zone even more vulnerable. And here you can check how this discharge was huge compared to other ones, and how is it called drop, and compared to these last 8 years, this was unprecedented here. So if you check the at national level this information, they really highlight how the fragility of these delta systems was evident during the storm, causing this flooding of large deltaic areas. And at a European level, the Ocean State report said that causing unprecedented ocean currents and flooding in Europe, as well as catastrophic damage. And both documents highlighted the importance of combining the use of satellite and in situ, as we did in the Mar Menor, for monitoring the coastal ocean against these critical events. So this is the similar approach that we generated for this case study, using the Acolyte processor for the atmospheric correction, as I explained, and also Google FIG for the flooding impact. So we can evaluate the before and after of the extreme event for all these 4 indicators. Again, spatial resolution, we have here an image of the same area for Sentinel-3 and Sentinel-2, and you can see the difference from the same day. So we need high, moderate spatial resolution and this multi-sensor approach with Landsat that we created in the server in the previous case study. So this is mainly the workflow. It has two two different parts, one for water quality, one for flooding. So the first one, we use level 1C images downloaded from Onda and applying in Acolyte this atmospheric correction and also the sun glint, the reflection of the sun that is very acute in mostly in summer, to take this information to level 2 using the dark the dark spectrum. Um, After that, that is very important to take this noise that we were talking about. We generate and we run these water quality parameters that are in line with the Water Framework Directive and the Marine Strategy Framework Directive. That is turbidity and suspended particulate matter, that we will see the difference between them, and chlorophyll A from this normalized different chlorophyll index that was published in 2012. For the flooding assessment, we don't need to use level 1 images from the satellites. It's enough with level 2. And we were evaluating also that. So it's even faster. And use a Google Earth engine, we can do it in a very systemic way. So we can monitor the before and after for the impact assessment. And how they perform between the satellites. So you can see here 2 control points. And here in this graph, you can see how Sentinel-2 is giving a lower reflectance compared to Landsat-8 in both cases. So that means that Landsat-8 is overestimating the remote sensing reflectance compared to Sentinel-2, but still they're in ranges that are very well aligned to in situ measurements. In the statistics, we can see also the consistent performance of Acolyte processor for the atmospheric and sun glint in low, moderate, and sanguine conditions, because we had other images with high sanguine conditions that we couldn't correct. Sometimes there are images that you just have to remove. The average revisit time is also for 4 days, and we could evaluate ecological conditions and impacts in this very heterogeneous and dynamic coastal area with complex features over the land-ocean transition. Here there's aquaculture, there's a lot of agriculture for rice fields, and also a lot of plant water into this one of the biggest rivers in Spain. So here we explained how remarkable value has these combined products with Lancet 8 and Sentinel-2 for these case studies for water quality. So here you can see, for example, a pre-post event for the turbidity parameter and some of the zooms. And how can we really approach the coastline that we couldn't do with Sentinel-3 because the pixels are too big, so we remove a lot of information from the coastline. Here you also can see the impact for flooding. It was a huge impact, as you can see also in zooms. And the time series for water quality. We could take these special temporal patterns from these images that they are so difficult to take from in situ measurements, because maybe they have 10, 12 points around all the delta that is impossible to take a whole image from that. So we could see here high suspension material multiplying per 10 the level of suspended particulate matter, and the same for turbidity. And we could see that these tools didn't reach the continental slope. So the sediment that was also taken out from this rainfall event, at least was moved by the current to the south. For this, we applied this semi-analytical model from NetSat. That is here, you can check this paper. We're using the red band. And turbidity, to differentiate these two parameters because they are so connected. To understand, turbidity is defined as the reduction of transparency of liquids caused by the presence of suspended particulate matter. So if we think, I will explain it like coffee. How dark is the coffee would be like the turbidity level, and the suspended particulate matter would be like the the powder of the coffee. That would be how we separate those variables. Here you can also see the time series for chlorophyll A and flooding. Um, we couldn't see any phytoplankton bloom during the event. For this, we took, well, this paper now is under review, so you will be able to check it soon, hopefully. And for this, we use this normalized different chlorophyll index that we need for performing this algorithm, the red edge band that we only have in Sentinel-2. That's why here we don't have the multi-approach with Landsat 8 as we had in here. You can check here we have 3 images from Landsat 8, and we write the revisit time for water quality monitoring. But here, this band is missing in Landsat 8, so we could only take Landsat 2 images, and as well for the NDWI, we only used Sentinel-2 images to have a better accuracy in this X exchange. So, arriving to the conclusions, I could say that as winter storm events can dramatically alter the ecological status of deltas and coastal lagoons, this synoptic monitoring is a real need through Earth observation to measure the impact in these vulnerable environments that coastal areas need from high spatial resolution and revisit time with robust performance and intercalibration, especially for this atmospheric entanglement correction. We propose an improved monitoring using multi-sensor approach at 10-30 meters spatial resolution and 4-day revisit time. Both missions prove essential in tracking water quality and measuring storm impact, which were not regularly monitored by this rapid eye from Copernicus Emergency in a cost-effective and systematic way. And the coastal science community can take advantage of all these products for operational management and early warning post-event monitoring system implementation. What I could say is challenges and future research. I would say improved of advanced sunlit and atmospheric correction and bio-optical algorithms for both satellites. As this is key for the quality of information we're taking out. Upcoming work for modeling seasonal water quality patterns, using more in situ measurements to calibrate and validate procedures, and additional statistics tools. And the future inclusion of Landsat 9 and Sentinel-2 CD that will be in orbit hopefully in 2025 and 2026. So with this, we can characterize the effect of storms in coastal waters and the water quality that is key to developing precise adaptation strategies under climate change scenarios. I just wanted to announce that now I'm working on another project, as Mary said, at the DLR, working on sequence mapping that is really linked to water quality. It's a really good indicator. It's trapping suspended sediments of the water, carbon, and a lot of stuff, and it will be out soon as well. We're using Sentinel-2 images. And yeah, thank you very much for your attention. I just wanted to encourage you to visit the observatory we have, to connect through LinkedIn if you're interested in collaborating or something, and to announce that we are preparing now a conference in Cadiz for June that is going to be in Spanish, but it's about remote sensing, and there's a lot of water quality works that are going to be involved. And the abstract deadline is going to be the 19th of January. So if you're interested, I encourage you to apply. Thank you very much. If you have any question, I'm going to try to reply.
Yes, thank you so much, Mar. I would love to promote your upcoming meeting, even doing that in Spanish. James had a question from earlier in the chat, which hopefully he will reiterate as well as ask his question now. Are you able to unmute, James?
Yes, thank you, Mary, and thank you for Mar. I hope I'm pronouncing your name correctly. For the presentation that you made. I think this is quite interesting because the way you have presented the presentation today was quite understandable even to very early on careers scientists. So I thank you for that. So my question is more or less the first question I had asked is the link to the application that you made. And the second one is whether you got to the point of forecasting, because I thought that you had mentioned that you were doing a little bit on forecasting. So I did not really catch that from the presentation. Thank you.
Yeah, okay. So the second one about the forecasting, thank you for your question. Um, I put like in future steps, like would be taking all this information that we have from satellites to calibrate, validate products, and also to model these seasonal water quality patterns. So that could include forecasting and um, modelical numerical modeling. And the first one I didn't catch it. Sorry for that. Can you repeat it?
I don't, sorry, I just mentioned that I wanted the link to your application, so I already got
Ah,
it.
okay, okay. I thought you were asking for a link in between the links. Okay, yeah, sure.
No,
I can put it in
thank you.
the
Yeah.
chat.
I
So as
think
well.
it was, for clarification, it was the one that the work that you were covering under the water quality in the lagoons, part two.
Yeah,
All
yeah, yeah.
right.
Yeah, you have to follow it.
Go ahead.
I just put it a link in the chat so they can
Great.
check it.
Thank you, Mar. I saw Alex had a hand up. Do you still have your hand up, Alex?
I can have, sure. Can you hear me?
Yes.
Okay. So thank you, Mark, for the presentation. What stage of your PhD are you on? Just so that I'm curious to know. Yeah, are you in the beginning of your
Yeah.
PhD or you're towards the end?
Now I'm gonna start the third year. So
Okay.
yeah, in the beginning of my PhD, I was more focused in these water quality algorithms, and now I'm more changing to seagrasses, but I'm still working on that.
Okay. So what I got mostly for your presentation is development of a platform for near real-time application to retrieve water quality parameters. And in
Exactly.
that in that case, would it be very interesting to know more about how those parameters are being validated. So you mentioned in your presentation that you had a few data points in the lagoon, but you also mentioned that there is an environmental agency continuous monitoring these lagoons. So I'd like to know if you have, for example, any plans for continuous validations of the products that are retrieved, as well as any plans for developing algorithms that are maybe more specifically tuned for the kind of environment that you're working, because maybe the global calibration algorithms are not particularly suited to that environment. So that is the first question. I have another one, but maybe we can start with this one.
Yeah, sure. Thank you for your question. Yeah, so I said that the regional government is taking this in situ data from the lagoon. This point I showed is from a specific collaborator. So he went there because we had to take this in situ measurements with a maximum of 30 hours of the capture of the image. So we have this buffer of time because if not, the water quality can change and the validation is not worth it. So we need to match up this taking of in situ measurements and the image acquisition. That's why we're not taking this regional government in situ measurements. but yeah, we have plans with the same collaborator to develop an algorithm for organic suspended matter, organic content matter, sorry, um, for this same lagoon. So this is now on the air, but we're working on it. But developing new algorithm is not on my plan of the PhD, because now I'm changing a bit the line. So yeah, but the developments are gonna be focused on that lagoon for sure.
Okay, thank you. I will. I think the other people have questions. Then I'll come back with another one later.
Okay, thank you.
Okay, Annabella asks, well, first she says, congratulations. Very nice and interesting presentation. Are you planning to include temperature maps in your analysis? If so, how would they explain? Can you explain how they would contribute to understanding the SPP, turbidity, and chlorophyll A dynamics?
Temperature, it's already added in the app, so you can also check it. We have an extension for marine heat waves, so you can check the historic and the base for the last 40 years, so we can do the percentiles. And yeah, it's directly connected, especially for chlorophyll A, because the higher the temperature, the better the environment for algae to grow. So yeah, you can check also the that parameters in the viewer, so you can see with the time series how it's changing the other parameters.
Thank you.
You're
James
welcome.
has James has another question.
Yes, one final question from me. You mentioned that you're also using Google Earth Engine. So how are you doing your atmospheric correction there,
Yeah,
and
I'm
how
using
and
the
how
Google
does
Earth.
it perform
Yeah, that's a good
in
question.
comparison to Acolyte?
Yeah, the Google Earth engine, we're using it for the flooding assessment. One of these future lines that we have in mind is to translate this Acolyte algorithm and put it in the Google Earth engine. That would be amazing, because that means that we don't have to download the images, we don't have to correct it in the desktop or in the server, and then we can use it there. I was well, last month I was presenting at the Google Outreach, one of my presentation, and I asked the guy like, do you have plans to include this Acolyte algorithm inside Google Ads Engine? And he told me that a lot of people uh, ask for it, and it's in future plans, but it's not in the first priorities. Yeah,
Thank you.
you're welcome.
Okay, back to Alex.
All right. I would like to also know, Mar, when you mentioned in your presentation that the high spatial resolution was very relevant for your study, but my impression looking at your images was that I could not see exactly, and I would like you to comment what is exactly that you gain extra from additional spatial resolution, especially when you're considering the spectral resolution that you're losing when you go from the ocean color observation design sensor like OCHI to it's 300 meters, sure, but your coastal lagoon is quite big. I could see all features were resolved and the coastal zone as well. So there certainly is a trade-off in terms of what you gain and what you lose when you change between sensors. Considering that the temporal resolution of OG is everyday observation, considering that it's tilted to avoid glint, which is not the case for the Nadir observation sensors, considering that those others were designed for land, there's more noise, there's less spatial, less number of wavebands and broader wavebands. So I would like for you to consider or ponder a bit, present to us your thoughts on why, what is the trade-off there? What you get extra that's relevant for you?
Yeah. So first of all, about the spatial resolution, if we're using Sentinel-3 for the water algorithm, we have to kind of mask the land. So we are losing a lot of pixels in the coast, and most of the changes started from that coastlines because of these wadis are taking all the fresh water into the lagoon, and when they're constantly um, putting this water in the lagoon, and these extreme events that you saw, the plume is huge, but most of the times it's not that visible. So we need that special resolution to check how the water quality is changing also in the coastline. And about the vents, of course, I'm with you. Like Sentinel-3, you have a lot of other vents. You can monitor better the water quality in terms of spectral resolution. But yeah, we're losing especially that spatial resolution. So yeah, also for validation, we're taking very local points and extrapolating a value of that point to a 300-meter pixel. I think it's quite worse than Sentinel in that case. But yeah, the processing costs a lot more. And in Sentinel-3, you have a daily basis image. So yeah, but we tried it. We're also processing images um, for HAPS in Galicia, in the north of Spain, for detecting some algal blooms. And Sentinel-3 sometimes is working, but you have to have a really dense patch to see it.
Thank you. I had I had a question for you, actually, a series of several questions. Excuse me. I did put them in the chat, but I wondered, could you comment on the who you know that uses your products, and are they pleased with the frequency and the resolution? Are they interacting with you to develop new products, especially the forecasting work that they might be interested in?
So for the regional government, yeah, we had a good feedback about the product, and we are aware that they are using it. But I don't know in which level they are using it for decision making. We just put that tool available, and we know they're using it, but not in which level. And we don't have any other feedback because, well, this lagoon had a lot of signals of deterioration, early signals, and they were not really taking care of it. So that's maybe another sphere, but they don't really want to know. Like it's not fair for them sometimes because they really defend these agricultural stakeholder parts, and it's really impactful. So there's a trade-off on that. But no, they're not developing with us things that I tried to collaborate with another colleague there, and he didn't even reply several times. So it's quite difficult to manage that. So opening this information to the public, it's gonna be useful for everyone because yeah, we need transparency in there.
Right. So you're saying that the decision makers might, because they have to make political decisions that may
Yeah.
be unfavorable with a sector, they may not be as willing to share the information as you guys are if you make it public, and then people can inform themselves. I wonder also if you could comment on the like maybe using this, because you talked about two different tools, one for the for Menor, and then you talked about the more coastal lagoon area. How transferable is this? Like, um, could you use it in the other area, the other boxes that you showed?
Yeah, yeah, yeah. Yeah, we can use it in all these boxes. I showed in the south of Spain and other parts of the Mediterranean because the taste water is mostly the same. So you can see in the application, everything, all these algorithms are applied in the same way in all these areas. So that's the good thing that you can transfer these algorithms to these different scenarios, and yeah, it's replicable through this acolyte processor because you really take out all this noise. That is what is key for a good product.
Right. Do you guys have any plans on serving that like you would with the more localized product?
And not really, but it's a good thing we can consider. Yeah, I will put that in mind of my supervisors to do it. Sure.
Oh, I just wondered. Yeah. I
Yeah,
know,
no, but it's a good idea. And we have also in the department a more social and economic department, so maybe yeah, maybe it's a good thing to collaborate.
right. Money makes the world go around, or at least the products get delivered on time, right?
Yeah.
So, okay. Are there any other questions from Mar? I want to point. Oh, wait, I see a hand up. I mean, that might be my hand. Yeah, it is my hand. Okay. Want to point out we have had a lot of webinars lately because we are leading up to the biennial meeting. It's also Geo Week this week, so there's a lot of stuff going on in other countries that are taking a lot of participants away from the audience that would have been here today. But the beauty of making the recording is that we make it available on our website, and often we get hundreds of hits of people viewing the webinar um, after the live presentation. So we want to thank everybody again for joining us today, and especially thanks to Mar for sharing her research and contributing to our understanding of at least the needs leading up to our discussion next week at the International Ocean Color Science meeting about the potential and needs for water quality forecasting. So if there are no other questions, another round of applause, if I can find out how to react in online for Mar. And the recording today will be posted on our website a little later. Also, a reminder, Mar, if you want to share your meeting announcement, even if it's in Spanish, with me about the AET 24 meeting, I'll be happy to promote that on our website and social media.
Sure, I will send it to you for sure. Thank you very much.
Thanks, everybody. Have a great day.
You too.